Hello friends. In some of our previous lectures, we have already started with this topic called as large sample test. We have seen in those lectures what is sampling, what are different types of sampling, what is the need of sampling. And the most important thing that we have learned in those lectures was the central limit theorem. Also, we have taken one lecture on the examples of central limit theorem. So in this lecture, we are going to advance further, we are going to proceed further with the next type of questions in large sample test. So students, I welcome you all to this channel, Pankaj Lade. In our today's session, we are going to understand some more concepts of large sample test. So let's begin. Now, what I have done here is I have written one question on the board and we are going to understand the entire concept based on this particular question. Now remember, the question or the type that I'm going to start, it is called as testing of hypothesis. This is the second type of examples that we are going to learn in this particular topic. The first type of examples that we learned was examples which were based on central limit theorem. The second type of examples that we want to learn is the examples based on testing a hypothesis. Now, the first question that should come to your mind is what is a hypothesis and how do we test it, isn't it? Now, I'm going to take this entire lecture stepwise, means there are few steps that you want to understand, and if you understand those steps very properly, you can be able to solve any given question on this type. Now, the first question that you should be arising is how do I identify that a given question is belonging to large sample test or not? So this question can be easily answered because I've already discussed with you that if a question contains sample size which is more than 30 or more than 30, then that particular question belongs to large sample test. So if you observe here, the question tells if a random sample of 100 Indians, isn't it? A random sample of 100 Indians is taken. So from there, it is pretty much clear that the question belongs to large sample test. Now, how do I come to know that the question is of testing a hypothesis? Now students, there are only three types of questions that you have to encounter in large sample test. The first type of question is solving the question based on central limit theorem. The second is testing a hypothesis, and the third type of question that we'll be discussing in our other lecture, the third type of examples that we'll be encountering is you have to compare the means of two different populations. So try and understand this thing very properly. I said the first type of examples are based on central limit theorem. The second type of examples we are going to test a hypothesis, and the third type of examples that we will be looking at is nothing but comparing the means of two population. So this question actually is of second type where I'm going to test a hypothesis. Now first of all, you need to know what a hypothesis is and how do I test it. When I say hypothesis, it is basically a statement, any statement you can take. It is a statement which is assumed to be true unless and until it is proved as false. Now this statement looks it seems to be a little bit weird. You listen to the statement one more time very carefully. I am telling you that a hypothesis is nothing but a statement which will be assumed to be true. So I'm assuming that the given statement is a true statement unless and until someone comes and proves that the given statement is a false statement. So I will consider that statement, the given statement, to be true unless and until someone is going to prove me false. So that kind of a statement is called as a hypothesis. Now if you take a look at the question goes like this. It is told in the question, can it be concluded that the average lifespan of an Indian is more than 70 years? That means he is asking you, can we come to a conclusion? Can we decide that the average lifespan of an Indian is 70 years? So I am telling you that the average lifespan of an Indian is 70 years, or it is more than 70 years. So this becomes a hypothesis. I am giving you a statement. I am telling you that the average lifespan of an Indian is 70 years. Now you sort out some kind of a procedure, you come up with a procedure so that you prove this statement of mine to be false. Then my hypothesis will become wrong, isn't it? My assumption goes wrong if you are able to prove that the given statement is wrong. That means the average lifespan of Indians is not 70 years. So you have to come up with the solution. I have already told my side of the story, isn't it? I have already told you that the average lifespan of an Indian is 70 years. So you should come up with a solution that the assumption that the statement is a wrong statement. Now how do we do it? So hypothesis you have understood. So testing a hypothesis means some kind of a question will be given to us, and in that there will be a hypothesis. I'll give you one more example to understand what a hypothesis is. For instance, there is a tire manufacturer. Okay, he manufactures tires, and he's telling, based on the entire experience so far, the average life of the tires is say 50,000 kilometers. Okay, so average lifespan of the tires is 50,000 kilometers based on the overall experience of the production. Now there has been some changes that has been done in the production process. We are doing some changes into the production process, and because of these changes I am telling you that the average life of this tire has now increased to 55,000, isn't it? 55,000 kilometers. So I have already given you a statement. I am telling you that I have changed my production process, and due to this change the lifespan of the tire has increased by 5,000 kilometers and the new lifespan is 55,000 kilometers. That means I have already told you my side of the story. You have to come up with a solution that my story is a false story. So this is called as testing a hypothesis. So here also in our question we have to test the hypothesis that the average lifespan of the Indian is not 70 years, isn't it? So students, the first step of the question, the first step of the solution to this question is going to be setting up a hypothesis. That means you are going to tell the statement over here as a hypothesis. Now students, there will be two different types of hypothesis that you want to set up here. One is called as a null hypothesis. Null hypothesis is that hypothesis which is to be taken as true, which is given in the question itself. He is telling that the average lifespan of an Indian is more than 70 years, or you can take that the average lifespan of the Indians is 70 years. So that becomes your null hypothesis. A null hypothesis, it is a hypothesis, so we are going to denote it by H. It is a null hypothesis, hence we are going to denote it by H naught. Then there will be something called as an alternative hypothesis. That means there will be your side of the story. My side of the story is given into the question itself. I am telling you that the average lifespan of an Indian, is 70 years. I am telling you that the average lifespan of the Indians is 70 years. So the step 1 now begins. In step 1 I will decide, or I will set up a hypothesis. So setting up a hypothesis. So as I said, there will be two different types of hypothesis. One will be the null hypothesis, which is my side of the story, and the other one will be the alternative hypothesis, which you are going to tell that the null hypothesis is a false hypothesis. That means I can now write the two hypotheses as H naught, which says that the average lifespan of an Indian is 70 years. Now, did you observe that the first part or the first line of the question is telling the average lifespan of an Indian? That means I am talking about the entire population of India, isn't it? I am talking about the entire population of India. That means I am talking about the universe over here. That means it is told to us that mu, we remember that mu is a notation that we make use to denote the mean of the population. For the population we denote it by mu, and for the sample, isn't it, we have denoted x bar as the mean. So you should know all notations very properly. Please watch my previous lectures on sampling and central limit theorem, as well as the first type of examples, to understand all this basic detail. So students, according to the question, the null hypothesis has become mu is equal to 70, isn't it, or 70 years if you want, you can write. So that becomes a null hypothesis. So you are going to tell now the alternative hypothesis, which is going to be denoted by HA. Okay, so there is null hypothesis, there is alternative hypothesis, and here you will tell, obviously it will be what? It will be population mean is not 70, isn't it? So I will write here mu is not equal to 70 years. So that becomes my first step. Now remember that both the statements at a time cannot be true. That means the null hypothesis as well as the alternative hypothesis, both of them cannot be true at the exact same time. Only one of them is going to be true. So either the null hypothesis comes out to be true or the alternative hypothesis comes out to be true. So I guess you have pretty well understood the first step. Now let us move on to the second step. Students, the second step is going to be step 2. It is going to be calculating the test statistic, obtaining the test statistic. So calculating test statistic. Now it means, see, we already remember that statistic is nothing but the parameters obtained for the sample, isn't it? We remember that there are something called as statistical parameters. When we obtain the statistical parameters for the sample, they are called as statistic. So here also I am going to evaluate the test statistic. It means I am going to solve something called as getting Z. Now you remember Z is called as a standard normal variate, and we remember that this question belongs to large sample test, isn't it? And for large sample test we have learned something called as a central limit theorem, which is going to give me X bar, isn't it? And then using the X bar I'm going to get Z. Z is called as the standard normal variate. So I'm going to get Z over here. So that Z becomes my test statistic. So we remember that from the central limit theorem, Z is given by X bar minus mu upon sigma upon root of n. I hope everyone remembers this formula from the central limit theorem. Now this is a very important statement that I'm going to tell you now. You make sure that you note down this statement somewhere in your notebook. It's a very important line. In your question, if you observe the question that is given to us, it is told to us that the average lifespan of an Indian is going to be 70 years. That means I already know that the value of mu is going to be 70 years. So mu is given to me 70 years. So this 70 years is actually the value of mu, isn't it? So mu is 70 years. Further, it is told to me if I take a random sample of 100 Indians, so this 100 Indians has become the value of n, isn't it? The sample size. So now I have the value of n, 100 Indians, that's the sample size. Further, it is told to me that they have an average lifespan of 71.8 years. What is this 71.8 years? It is an average lifespan. It is an average lifespan of whom? The Indians, the sample that we have taken of 100 Indians. That means this 71.8 years is the value of X bar, isn't it? It is the mean of the sample size that we have taken. So we have X bar value. So there is X bar value, there is mu value, there is n value. What is left is sigma. Now do you know that sigma is nothing but the standard deviation of the population? Remember the terminologies very properly. Sigma is the standard deviation of the population. If you read the entire question, nowhere standard deviation of the population is given to us. We are given the standard deviation of what? Standard deviation of 8.9 years, but of what? It is of the sample. So this is one point that you want to remember. Sometimes in the question it might happen that instead of giving you the standard deviation of the entire population, they might give you the standard deviation of the sample. Instead of giving you the standard deviation of the population, they might give you the standard deviation of the sample. So even though the standard deviation of sample is given, we should not worry, because we are considering, or we are doing problems on large sample test. So we are taking a very large sample. So for large sample test, note down this statement. For large sample test, the standard deviation of the population and the standard deviation of the sample can be taken equal. Standard deviation, that is sigma of population, isn't it? And the standard deviation of the sample can be taken equal. That means I can say, if I say that the standard deviation of the sample is denoted by S. Okay, so S is 8.9 years. 8.9 years is the value of S. So I can say that this same formula can also be written as X bar minus mu upon S upon root N. So it does not matter whether the standard deviation of the sample is given or the standard deviation of population is given. Whatever it is given to us, accordingly I will change my formula. So I'm going to get the value of Z from here. So students, the value of Z would come out to be, so X bar is given to me as how much? The value of X bar is 71.8. So I'll write here 71.8 minus the value of mu, it is 70 years. So I get 70 here upon I'll put the value of S. So S is given to me, standard deviation is given to me 8.9. So I write here 8.9 divided by root of N. So root of the value of N is 100. So root of 100. So obviously I'll need a calculator to get this value. So students, I'm going to make use of the calculator to find this value. So the value comes out to be, let me quickly get the value. So it is 71.8 minus 70 divided by 8.9 upon root of 100 is 10. So I write 8.9 divided by 10, or I can say 0.89. So the value comes out to be 2.022. So I'm going to write it over here, 2.022. 2.022. So that's the value of Z. Now students remember, this value of Z that you have obtained is modulus of Z, and the value came 2.022, or you can only take it as 2.02. Now when I say mod of Z, it means it is positive as well as negative value. So this value of Z that I have obtained here is called as the calculated value of Z. It is called as the calculated value of Z. So students, I hope you have understood so far what the steps I have taken. I have so far taken two steps. The first step is setting up a hypothesis, and the second step is calculating the test statistic. Now let's move on to the third step. So students, now let's proceed with the third step. Now the third step is an important step of this kind of questions. So you understand the third step very properly. The third step is called as setting up levels of significance. Now you understand this word very properly. The third step is going to be setting up levels of significance. So that's my step 3. Step 3, setting up levels of significance. Setting up levels of significance. Now sometimes we will call it as level of significance, and sometimes we'll call it as levels of confidence. So I can say, or setting up levels of confidence. Now they are exact opposites of each other. A level of significance and a level of confidence, they are exact opposites of each other. Now let's try and understand what is a level of significance or what is a level of confidence. Now take this statement. We are told in the question it is told to us that the average lifespan of the Indians has to be 70 years. Now how can I come to this conclusion? So I need to tell with some confidence that the average lifespan of an Indian is going to be 70 years. So I have to be with some kind of an argument, isn't it? And that argument will be provided by the calculated value of Z and the level of significance, or we say the level of confidence. Now what I'm going to do here is I'm going to first draw the standard normal curve. I hope everyone now knows what a standard normal curve looks like. Now students, I want you to simultaneously note down the things that are shown on the board also, because this is very important, and because lack of space I am going to remove this diagram from here. We are just going to write the calculations here. So make sure simultaneously you are also noting down these things. Now we remember that the standard normal curve is a bell-shaped curve, isn't it? So bell-shaped curve is given to us, and On the right hand side here, we know that Z is 0, isn't it? Z is 0 here. And on the right hand side, obviously Z is greater than 0, and here Z is less than 0. So on the right hand side, there are 50% of the values, isn't it? 50% values are on the right hand side and 50% values are on the left side, isn't it? So there are 50% values on the right and 50% values on the left. So Z is less than 0, Z is greater than 0. Now when I say I can be 95% confident that my given hypothesis is true, I am telling that 95% confidence is there that my given statement is true. That means I am telling that 95 values out of 100 values. That means, see, there are 50 values on the right, 50 values on the left. So when I say 90%, or I can say, let's begin with 90% confidence level. Now, students, there will be 3 different types of confidence intervals, or you can say level of significance. These are standard ones. You can have any other ones also, but the standard ones are 1% level of significance, 5% level of significance and 10% level of significance. So there are 3 different types of levels of significance that you can usually have: the 1%, the 5% and the 10%. Now if nothing is mentioned, see in the question nowhere it has been mentioned what is the level of significance, isn't it? So whenever the question does not provide you with any information of level of significance, by default you will take the level of significance as 5%. So note down this statement. There are 3 different kinds of levels of significance. Don't worry about what is level of significance at this moment. I am going to definitely explain you what is level of significance, or you can say what is the level of confidence. So have some patience. Just note down that there are 3 different types of levels of significance: 1%, 5% and 10%. For explanation purpose, right now I am taking 10% level of significance. So if I take 10% level of significance, that means 90% of the values will lie within the confidence interval. So I've drawn 2 lines over here. This much part starting from Z equal to 0 up to the line that I've drawn, this much part contributes towards say 45% values, and again from Z equal to 0 to the left side, again it contributes towards another 45% of values. That means within this region, how many values are lying? Within this region, 90% values are lying. Now, if you go to the area under the curve, area under the standard normal curve. So you remember that there is a table available for the area under the standard normal curve. So if you go in the table and find out the value for 0.45, try understand. I am not asking you to go and see the value of 0.45. No. You should go into the table, go inside the table where the values are recorded, isn't it? And there you find where this 0.45 lies. So students, if I show you the table of standard normal curve looks like this, isn't it? Now, I don't know how much of this is visible to you, but you can just make an idea of it. So a standard normal curve, the area under the standard normal curve, the table looks like this. Now what you have to do is you have to go inside this table here and you have to find the value of 0.45. So 0.45, if you observe 0.45, so exact value of 0.45 is not available. So students, 0.45, I can say it is somewhere between 1.6 below 0.6 and 0.7. So there is a column of Z in which there is 1.6 and then there is a row of 0.06 and 0.07. These 2 values when combined together and take an average of it will give us the value of 0.45. So again I am telling, I am not finding 0.45 in the first column. We will find 0.45 inside the table over here where 0.45 lies. Now this 0.45 is not exactly present in the table. It is somewhere between 1.66 and 1.67. Somewhere between 1.66 and 1.67. So what I'll do is I'll take some random value, say 1.6 6 and 6, 7 it is given to us. So you can take 1.665, isn't it? So that will be giving us the value of 0.45. Now remember, usually these values are provided. So here what I'm going to do is, I'm going to take the value of Z alpha. It is called as Z alpha. We call them as critical values of Z. Note down the word that I'm using. They are called as the critical values of Z. Now for instance, as I said, I am talking about 90% of confidence interval, isn't it? So I am telling that there is a chance, there is a 90% chance that the given value, the given statement, the given hypothesis is going to be a true hypothesis. So this Z alpha, I will take say 1.64. Now this is a standard value which will be given for 10% level of significance. So 90% level of confidence or 10% of level of significance, they both convey the same message. 90% level of confidence or 10% level of significance, they both convey the same message. They are telling us that if you are telling level of significance is 10%, that means 5% on the right and 5% on the left, that covers 10%. So this part of the curve is called the area of rejection. This part is called the area of rejection. So I'm going to denote it here with area of rejection. So here also I'll call it as area of rejection. Okay, now try and understand. If the calculated value of Z, note down this statement very properly. If the calculated value of Z, which is obtained over here, if this value lies within the area of rejection, then the null hypothesis will be rejected. That is why it is denoted by area of rejection. So if the calculated value of Z, so it is 2.022, that means if you are telling that Z alpha is 1.64, this is for 90% confidence interval, isn't it? So this is 90% confidence interval, or you can say it is 10% level of significance. Both of them are going to convey the same message. So if the calculated value of Z lies in the critical region or the area of rejection, then your null hypothesis will be rejected. So area of rejection you can call, or you can call it as a critical region. You can call it as a critical region, isn't it? And these values are called as a critical values. So here this region is called as region of confidence. It is a region of confidence, or we can say it is the confidence interval. It is called as confidence interval, or you can say this is also called as the fiducial limits. It is fiducial limits, FIDUCIAL. So confidence interval you can call it as fiducial limits. Sometimes it can be also called as confidence limits, or you can also call it as confidence limits. Okay, so the region that we have now, try and understand what is region of confidence. It simply tells you, if you are telling that the confidence interval is 90%, it simply means that there is a 90% chance that the given sample, isn't it? The given sample belongs to the given population where the mean is going to be 70 years. The average lifespan is going to be 70 years. So the hypothesis will be accepted. So students, if the calculated value of Z falls within the confidence limit, that means your null hypothesis will get accepted. And if the value of Z, the calculated value of Z, falls in the critical region or the area of rejection, then your null hypothesis will be rejected and the alternative hypothesis will get accepted. So that is one very simple meaning of level of significance or level of confidence. Students, level of significance and level of confidence are opposites of each other. If 10% level of significance is given, that means 90% level of confidence is given. If 5% of level of significance is given, which is in general what we will be taking whenever the question does not have level of significance given to us, we will always take it as 5%. So 5% level of significance means 95% confidence limits, or you can say level of confidence is 95%. And lastly, it is 1% level of significance and there is 99% level of confidence. So out of the three, any one will be given to us. Now, this is very important part you understand. If the hypothesis came true, if the hypothesis came true, it does not mean that the statement is proved. It only tells you that the given sample is taken from the population. That is only the meaning of hypothesis is getting accepted. Similarly, if the hypothesis got rejected, it does not mean that the statement is wrong, isn't it? It simply means that the sample that we have taken does not represent the entire population. Very simple meaning it is. So acceptance of the hypothesis or the rejection of the hypothesis, it is not going to prove the validity of the statement. Now students, it is slightly, what you can say, slightly difficult to digest what things I'm going to tell and the things that I'm telling you. So do not worry at all, do not take too much load of these things. Just remember very simple things. Three types of level of significance: 1%, 5%, 10%. Most of the time 5% level of significance is given to us. When I say 5% level of significance, it simply means it is 95% level of confidence. Level of confidence and level of significance both convey the exact same meaning. Level of significance will set up a parameter, isn't it? So if there is, say, 95% level of significance, if I have 95% level of significance, then the values of Z alpha are going to be something like this. For 95% confidence interval, or I say 5% level of significance, the values of Z alpha will become 1.96. Z alpha, it is 1.96. Now, one very important thing I missed out here is, here Z alpha will be positive and here it will be negative. So I'll write here minus of 1.64. So I'll write here minus of 1.64, and likewise it will be minus of 1.96, minus of 1.96 it is. So students, if 5% level of significance is given or 95% level of confidence is given, so this is the value that you should be using. Z alpha is negative 1.6 and positive 1.6. So this is for 5% level of significance, we say LOS. And similarly students, if it is for 1% level of significance, so for 1% level of significance, the value of Z alpha becomes, for 1% level of significance, the value of Z alpha becomes minus 2.58 and it becomes here plus 2.58. So it's minus 2.58 to plus 2.58. So these are different levels of significance. The first one that I've written is for 10% level of significance. So I'll write here 10% level of significance. This is 10% level of significance. The next one is for 5% and the next one is for 1% level of significance. So these values are for 1% level of significance. Okay. Now, if your calculated value of Z lies within the confidence limit, then the hypothesis, the null hypothesis will be accepted, and if the calculated value of Z lies in the area of rejection, then the null hypothesis will be rejected and the alternative hypothesis will be accepted. So that is a very simple meaning of setting up levels of significance. So in our case, in this case, I'm going to set up the level of confidence, or I can say the level of significance at 5%. So students, I hope you have understood what this entire concept was, and I hope that you have also noted this entire thing down in your book. If not, please make this part first of all in your book very properly, because now I'm going to remove this part from here, and then we'll be moving on to the next part or the next step of the problem. So students, as I said, we are going to solve this question using 5% level of significance, or you can say 95% confidence limit. So for that particular case, if I try to draw the diagram, a simple diagram, I hope you already understood the previous diagram that I've made, then the region of confidence will have values Z alpha is equal to 1.96. So on the left it is going to be minus of 1.96, and on the right it is going to be plus 1.96. This region on the right of this value, the critical value, isn't it? This is called as the critical value of Z alpha. This is the critical value, isn't it? Because the value of Z will be on the right as well as on the left. So these are called the critical values. So right of the critical value, left of the critical value, this is the area of rejection, isn't it? So this is the area of rejection. So I have set up a 5% level of significance. So I'm going to write here 5% level of significance. 5% level of significance. The same thing can be concluded with 95% level of confidence, isn't it? So now the calculated value of Z. So now the next step is to find the critical value. So as I said, step 4 is going to be finding the critical value, but you already know that the critical value is already obtained by us, isn't it? Step 4 is finding the critical value, isn't it? Finding the critical value. So the critical value that I've got here, for 5% level of significance. So level of significance is 5%, and the critical value is taken as plus and minus 1.96. Now, or I can say mod of Z alpha, that is mod of Z alpha is 1.96. Now, how do I come to my conclusion? I have already told you, isn't it? If the calculated value of Z lies in the area of rejection, the region of rejection, you will discard the null hypothesis and you will accept the alternative hypothesis. What is the value of the mod of calculated value of Z given to us? The calculated value of Z we have got 2.02. So 2.02 is obviously beyond the critical values, isn't it? 2.02 is beyond the critical value. So I can note the calculated value, say here, this is the calculated value. Z calculated minus of 2.02. Z calculated, it is 2.02. So the value, the calculated value is lying in the area of rejection. So that is your step 5, students. Step 5 is decision, taking the decision. So the step 5 is going to be now decision making. So I'm going to decide decision making, isn't it? So I'm going to decide whether the null hypothesis must be accepted or the alternative hypothesis must be accepted. So I can observe here that the calculated value of Z is far more greater than the Z alpha, the critical value of Z. So when this thing happens, as you can observe, for 5% level of significance, the calculated value lies in the area of rejection. So therefore I can say the null hypothesis is rejected. Now when I say that the null hypothesis is rejected, it means that the average lifespan of an Indian is not 70 years. Isn't it? Simple conclusion. The average lifespan of the Indian is not 70 years based on the lifespan that you have got for the sample. Isn't it? For the sample it was 71.8 years. From here you cannot conclude that the average lifespan of the Indian is going to be 70 years. That is what the simple conclusion after solving this problem has come up. Now let's change the level of significance. Let's see what happens if I change the level of significance. Students, this was for 5% level of significance. If I raise it to 1% level of significance, if I raise it to 1% level of significance, what changes you are going to observe here? This Z alpha value will change. It will become 2.53, isn't it? So value of Z alpha changes to 2.53. So the values of Z alpha is going to be 2.5. Now students, it can vary, isn't it? So sometimes it is 2.53, sometimes it is 2.58. Usually the level of significance will be provided in your question. So for 1%, 5% and 10%, some values will be provided. So for 5% it is always 1.96. For 1% it might vary from 1.64 to 1.68, sometimes 1.64, sometimes 1.65, 66, 67, 68. And for this final value, the 1% level of significance, it will be around 2.53 to 2.58 somewhere. So now I can say if I increase the level of significance to 1%, isn't it? If I take 1% level of significance, what changes will happen? The value of Z alpha will change to 2.53, 2.58, whatever it is. So as soon as it changes to 2.53 or 2.58, the calculated value of Z automatically lies within the level of confidence. Can you understand? If this becomes 2.5, calculated value is 2.02. So obviously 2.5 is far more away than 2.02, isn't it? So 2.02 value lies within the confidence limit. So at that time you can say that the null hypothesis will be accepted. That means the given sample is resembling the population, and the population has an average lifespan of 70 years. So this is what the simple meaning of this question was, and this is how the question is solved. So in all there are 5 steps. First step is setting up the hypothesis, calculating the test statistic, setting up the levels of significance, or we can say levels of confidence, but remember they are both opposites of each other. The next one is to find the critical value. There are 3 different kinds of level of significance: 1%, 5% and 10%. One of them will be taken, isn't it? So usually we take 5% level of significance. The critical value is 1.96, positive and negative. If your calculated Z lies within the confidence limit, you will accept the hypothesis. If it lies outside the confidence limit, that means if it lies in the area of rejection, then you will reject the hypothesis, and finally you are going to take the decision. If it's a simple concept, isn't it? If the calculated value is more than the critical value, reject the hypothesis, and if the calculated value is less than the critical value, you will accept the hypothesis. Now students, I hope you have understood what this concept was. In this lecture, in this session, we have taken the second type of examples for large sample test, where we have taken the type of questions based on testing a hypothesis. So you have understood what a hypothesis is and how to test it. Now students, obviously one question is not enough to understand. We will take at least one more question on testing a hypothesis, and then we will move on to the next type of concept. Okay students, now let's take one more example so that our concept becomes very strong. Now in the next question that I've written over here, it is given to us is the mean breaking strength of cables supplied is 1800. So the mean breaking strength of the cables that are supplied is 1800. From this line, you have understood that the information is provided about the population, isn't it? So the mean breaking strength is 1800 and the standard deviation is 100. So here in this question, we are given the standard deviation of the population. The previous example that we discussed, in which we have also understood the entire concept, there the standard deviation of the sample was given. So you now remember, either the standard deviation of sample is given or of the population is given, does not make a difference, because for a large sample, did you observe? The problem is of large sample, a sample of 50 cables, isn't it? So from here I have understood that the question belongs to large sample, and for a large sample the standard deviation of the sample and of the population both are taken as same. So now he is telling that the mean breaking strength of the cables is 1800, standard deviation is 100. So from here I can write the data something like this. So for the population, what is given to us? For the population, what is given to us? For the population, it is told to us that the mean, that is mu, is 1800, and the standard deviation, which is sigma, is given to us 100, isn't it? So mu is 1800 and sigma is 100. Further, for the sample, what is told to us? The size of the sample, n, it is given to us, the size of the sample is 50. So n is 50, isn't it? And the mean breaking strength of the sample was found to be 1850. So x bar is given to us 1850. So what is he asking? He is telling that by modification in the manufacturing, it is claimed that the breaking strength has now increased. That means he is telling that the mu is not same. The breaking strength, which was 1800, is not same now. It has increased, isn't it? So can we support this claim? Can we support the claim from the sample that we have taken out? So a sample of 50 has been taken out, and from that sample, can we support the claim that the breaking strength has increased? So it's a very simple question again. The first step is going to be deciding the hypothesis. So what is the hypothesis going to be here? There will be a null hypothesis, there will be an alternative hypothesis. The null hypothesis is, I am telling that the mean is how much? 1800, and you are telling that after taking the sample the mean has increased, isn't it? So I can write here step 1, setting up the hypothesis, isn't it? Setting up the hypothesis. So first of all, I'll write the null hypothesis, which is denoted by H naught, and it is told that mu is 1800, isn't it? And then I will write the alternative hypothesis, which is denoted by HA, and here I will tell that mu is not 1800, isn't it? Further, I will say step 2 is to get the test statistic, isn't it? To calculate the test statistic. So calculate test statistic. So if I get the test statistic, that means I will say Z is given by x bar minus mu upon sigma upon root of n, isn't it? So the value is going to come. So x bar is 1850. So I write here 1850 minus mu. So mu is going to be 1800. We knew mu is 1800. So I write 1800 upon sigma upon root n. So what is the value of sigma that I know? The value of sigma is 100. So I'll write here 100 upon root of n is 50. So students, I definitely want to calculate this value. The value that I'm going to get is mod of z. So I'm going to make use of a calculator. Let's take the help of a calculator to get the values. So I have 1850 minus 1800, that's 50 divided by 100 upon root of 50. So the value, students, comes out to be 3.53. So the value is 3.53. So I'm going to write the value as 3.53 here. This is the calculated value, isn't it? So 3.53, this is calculated value. So Z calculated, it is 3.53. Further, the step 3 is set up the level of significance. So there is 1%, 5% and 10% level of significance. So setting up a level of significance, isn't it? Level of significance. So we have 10% level of significance. LOS is 10%. So you remember that Z alpha for 10%. it was given as 1.64, isn't it? So 1.64 to 1.668 it is given to us. Then level of significance, if I take 5%, then Z alpha is definitely taken as 1.96, and obviously positive and negative both values come, isn't it? And if I take the level of significance as 1%, Z alpha is going to be plus and minus 2.58, 2.53 to 2.58 it is, isn't it? So these are the values. So if I try to draw the diagram over here and put up the region of confidence, so this is Z alpha, so negative 1.64, or Z alpha can be negative 1.96, or Z alpha can be negative 2.58. Students, only one of the value has to be selected, and by default it is 5%. If it is nothing mentioned in the question, you always take it 5%, isn't it? So I'm discussing for all of the levels of significance. Let's see what happens. And here Z alpha is going to be 1.64, again Z alpha is 1.96, and it is 2.58. This is entirely region of rejection, the region of rejection, isn't it? And what is the value of Z that we have got from the calculated part? The Z calculated is 3.53. So obviously 3.53 is a value which is definitely going to lie in the rejection area, isn't it? This is where 3.53 is going to lie. So Z equal to positive 3.53, and this is Z equal to negative 3.53. So whatever level of confidence you take 1% or 5% or 10%, every time the calculated value will lie in the region of rejection, the area of rejection. That means every time what is going to happen? The null hypothesis is going to get rejected. So I can say here, so setting up sorry, the setting up level of significance is done. Step 3. Step 4, it was to get the critical values, isn't it? So we write the critical values. So we have written the critical values here denoted by Z alpha. So it is plus and minus 1.64 for 10%, or plus and minus 1.96 for 5%, or plus and minus 2.58 for 1%. So whatever question is given to us, accordingly the level of significance and the critical values will be selected. So if I select 5%, this is the value 1.96, isn't it? So step 4 is done, and finally I'll write the step 5, which is the decision making step. So I observe that I'm 3.53 is telling me that I have to always reject the null hypothesis, and the null hypothesis was mean is 1800. That means the mean is not 1800. That means I can say from the new technique there is a possibility that the breaking strength must have increased, isn't it? The null hypothesis is getting rejected. So students, this is how the type 2 of large sample test questions are to be solved. Now I hope you have understood this concept very properly. Now I believe that this part of the chapter is slightly difficult than what we have learned in the previous lectures. Now students, this topic, statistical analysis, this is slightly challenging topics, isn't it? You cannot understand them just by listening to the lectures. You have to practice these questions at home very properly. So students, make sure whatever lectures you have watched so far, you are understanding it very properly. If possible, watch it again. Watch it as many times as you want, but understand the concepts first, and then I am very sure that you can tackle any question based on the second type of problems, isn't it? Where we have seen how to test the hypothesis. So students, I am going to leave you over here. The next lecture we are going to take another type of questions, which will be the last type of questions of large sample test. So students, you all have a very great day ahead. Thank you very much.